this sizes. I have the truss at the bottom, and I have the span over depth ratio for the truss is L by 10 because I will take the lower number. If I have this span over depth ratio, my span, let's say I have span of I will take 16 meters. Okay, 16, or you can go for 24. Let's say 24 meters. 16 meters is fine. Okay, so the truss depth is 16,000 divided by 10, that is 1600. Now we got the depth of the truss, but one thing we don't know is the size of this bottom, and we don't know this members. I want this member sizes. I want this sizes and this size as well. Not the precise size, but the I want this sizes. I don't have this sizes. What I can do is I know the truss span, right? I have the loading as well, right? Suppose my loading is W over that, and what I will do, I'll calculate the bending moment. That would be WL square over 8. This W you have to quickly calculate because the same thing that we did in the column calculation. Okay, so you calculate the WL square over 8. Once this is uniform load on the truss. Let's actually calculate this as well, because we have the unit UDL of 5 plus 1.5 superimposed dead load plus 7.5 we have for the concrete slab. Okay, and this spacing was 8 meters, right? We need to multiply with this 8 and 1.5 for the load factor. Okay, how much is that? 168. Okay, 168 kilonewton per meter, right? So my bending moment would be 168 times 16 square over 8. 5376 kilonewton meter. Okay, now I have shared in the previous calculation to calculate the actual force in this members, right? So my N is M by D. 5376 divided by 1.6 meter. My actual force is 3360 kilonewton. Now what you do, you know this 3360, you have the section properties of steel. You check this 3360 and you give the section sizes, right? Okay, two lines quickly done. Trusses.